grounding is invisible. You never see it doing anything until the moment something faults. And in that moment, the ground is the only thing standing between a live fault and a person. Get it right, and a breaker trips in a fraction of a second. Get it wrong, and a metal cabinet can sit there quietly energized, waiting for a hand. In this video, I will explain what grounding actually is and why it saves lives and equipment. Then the three words people mix up the most: ground, neutral, and earth. And finally, how it works inside a control panel. Let us make the invisible visible. Quick note before we dig in. This is from PLC Simulator, where you can practice control panel wiring and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to grounding. So what is grounding really? Strip away the jargon, and it is one idea. A grounding conductor is a deliberate, low-impedance path back to Earth and back to the source. Low impedance just means low resistance to current, a wide, easy road. Normally no current flows on that path at all. It just sits there. Its whole job is to be ready. When something goes wrong, it gives fault current somewhere safe and predictable to go, instead of letting it find its own way, through a chassis, through insulation, or through you. That is the entire concept. A safe road that stays empty until the day it is needed. Now why it matters. The headline reason is safety. Picture a live wire that chafes through and touches a metal enclosure. Without a ground, that enclosure is now live. It waits silently for someone to touch it, and the only path to Earth is through that person. Now at a ground bonded to the enclosure, the fault current rushes down that low-impedance path instead. The current spikes hard, and the breaker or fuse trips almost instantly. The metal never stays live for more than a heartbeat. That is the job. A ground turns a silent, deadly fault into a tripped breaker you can go and reset. Safety is the headline, but grounding does two more jobs. The second is reference. Grounding gives every device a shared 0-volt baseline, so they all agree on what zero actually means. Without a common reference, two devices can disagree about ground, and your signals drift. The third is noise, or EMC. A solid ground gives electrical interference a path to drain away to Earth. Drives, contactors, and switching supplies all throw off noise. A good ground sinks it, instead of letting it ride into your sensitive analog signals. So 3 jobs in total. Trip the fault, set the reference, drain the noise. Here is where people get tangled. Ground, neutral, and Earth. Earth is the simplest. It is the actual planet, the dirt, reached through a ground rod or the building's grounding electrode. Neutral is a current-carrying conductor. In normal operation, the neutral is the return path for the working current. It does a job every second. The protective ground is the opposite. It normally carries no current at all. It only carries current during a fault. And here is the fact that confuses everyone. Neutral and ground are bonded together at exactly one place, the main service or the source. After that single point, they stay separate all the way downstream. Bonded once, separated everywhere else. Tie them together a second time downstream, and you create a sneak path that quietly defeats the whole protection scheme. Now bring it into a control panel, where 3 grounds do 3 jobs. System grounding is the bond at the source. It ties the power system itself to Earth, the reference for everything. Equipment grounding is the green wire. It bonds every metal enclosure, door, and backplate together and back to that point, so no chassis can ever go live. And signal grounding is your 0-volt reference for the DC and the sensors. This is where panels go wrong. The rule is single-point grounding. Every signal ground returns to one common spot in a star. If instead you let 2 grounds form a loop, you get a ground loop. That is a circulating current that injects noise straight into your analog readings. One reference point, like the spokes of a wheel, never a ring. For the hands-on wiring, the control panel video is linked below. So here's what to walk away with. Grounding is a low-impedance path to Earth and source. It stays empty until a fault. Then it trips the breaker instead of energizing metal. Neutral carries current and ground does not, and they bond at exactly one point. And in a panel, bond every enclosure and keep your signal ground single point to dodge ground loops. Get those 3 ideas, and grounding stops being a mystery. Now, go make it concrete. If you want to practice control panel wiring and grounding hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.